copper is a critical metal needed for building our future. However, global demand is expected to exceed supply at some point in the next 5 to 7 years. Though the demand for copper is increasing rapidly, it must be produced in an environmentally sustainable way. Draslovka's Glycine Leaching Technology, or GLT, is helping copper producers reduce their environmental footprint with the help of a remarkable reagent, glycine. A commonly used nutrition supplement, it is biodegradable and non-toxic. GLT assists in reducing the amount of chemicals required. Because glycine is a recyclable reagent, it can be reused without losing efficacy. Recycling glycine can significantly improve the operational costs of heap leach operations and improve project economics for stranded, high-acid consuming deposits, such as carbonate-hosted copper oxides. Through glycine's reusability and alignment with ESG principles, GLT not only leaves a positive impact, but also sets a new standard for responsible mining practices. Partner with Draslovka to reduce costs and optimize recovery in your copper operation.
Hello and welcome to our webinar on glycine leaching technology for base metals. We're very excited to share with you the intricate details of this groundbreaking technology. We've got quite a few experts today. If you could move to the next slide, Monet. Today we'll be hearing from Dr. Glenn O'Malley. He's our Global GLT Metallurgy Manager located in Perth, Australia. We'll also be hearing from Dr. Elahe Karami, a developmental metallurgist focusing on copper, as well as Dr. Yang. She'll be speaking with us about nickel and cobalt applications and case studies. And finally, we'll be speaking with Mante Kharia from South Africa. She's our GLT technology leader for Africa. Dr. Glenn will be taking us through the GLT technology. He'll also be explaining the value proposition and the R&D technologies that we are developing in our innovation lab in Perth, Australia. Dr. Elahe will take us through a case study for copper. We'll also go through case studies for nickel, PGMs, and gold. Mante will be speaking with us about our engagement model with clients, what the process is that we follow. And then just a reminder to post all your questions in the Q&A and like the questions that you want us to answer first. I'll hand over to Dr. Glenn O'Malley to take us through the technology.
Thank you, Megan. Today we'll have a quick discussion on what is the glycine leaching technology, GlyLeach and GlyAm, which is used for base metal extraction, but also highlight the other technologies that Draslovka is part of the glycine leaching technology. So what is, well, the introduction, Draslovka is a CN-based expert chemical company who believes in the R&D development of technologies, and which is why they're bringing this innovative technology of glycine leaching technology to the mining industry. It can help the mines to optimize metal recovery and also reduce operating costs and allow probably some critical minerals to be extracted from untapped resources to recover the value of those situations. It's cutting edge technology and is very sustainable, and we're happy to bring it to the metallurgy industry. So what is glycine? Glycine is an amino acid. It is non-toxic, it's fully biodegradable, and it is used in the food as a food additive in both human and animal foods. It has sugar-like appearance and taste. It's unique in its ability to selectively leach base and precious minerals and leave gangue minerals like iron, magnesium in the residue. It's not chemically consumed, so as a primary reagent, it is recoverable and recyclable, and that adds added benefits in the cost savings of the process. It works synergistically with a range of additives. That's with, say, with star levels of cyanide in the glycat process for leaching of complex gold ores with elevated base metals and pre-milling gold ores. This slide highlights the 4 different processes which we're bringing to market. where the most advanced and current application is to market is Glycat, which is a pairing of glycine with cyanide for leaching of gold, silver, and PGMs. Then the other technologies are in development, but that is the GlyLeach for base metals of copper, nickel, zinc, and cobalt, and the precious metals of gold and silver. And the other base metals of GlyAm process, which is a pairing of glycine ammonia, and that's the leaching for copper, nickel, zinc, and cobalt. And our acidic option, which is GT, which is a glycine diurea, which is for the leaching of gold and silver. And we also found it leaches copper. So this slide is to highlight the various forms of our processes. The number of samples we tested in the various forms of our GlyLeach process and GlyAm process, where we tested whole wall, concentrate leaching, and tails leaching. Whole wall samples we tested is nickel cobalt sulfide samples, cobalt oxide, premium gold ores, PGM sulfides and oxides, and carbon hosted base metal oxide ores and sulfide hosted base ores. The concentrates, we looked at nickel and cobalt flotation concentrates, lead zinc flotation concentrates, copper sulfide flotation concentrates, PGM sulfide flotation concentrates, and this is also what we have done on the tails leaching of those streams. This concludes my part of the presentation, and now pass you on to Alay to discuss some copper examples.
Thanks, Glenn. Hello, everyone. My name is Alahe, and I will give you a presentation about our case study for copper using glycine leaching technology. So yeah, the glycine leaching technology, if that applies in alkaline system, can offer simple and selective method to extract both base and precious metal, and there would be little amount of going in the left in the PLS solution, and glycine added to the leach can be recyclable, and it can enable between 15 to 90% depending on what recovery method that we use. There are some value in using of the glycine leaching technology for copper extraction, like treating carbonate-hosted copper oxide for both base and precious metals. Glycine leaching technology is a selective extraction method for both base and precious metals. It can enable recovering using their existing recovery methods such as ion exchange, solvent extraction, or precipitation. There are some ESG benefits like reducing the amount of chemical, and it's enabled for the previously uneconomic marginal ores, the one that use high amount of acids. And it's beneficial for polymetal extraction of the both base and precious metal using same leaching process. Here's the first example of carbonate-hosted copper deposit in Chile. This one, for this specific sample, there was a conventional acid heap leaching of this deposit, and it was unviable because there was a huge amount of acid consumption. It was more than 200 kilograms per ton. So we used a recyclable glycine that delivers around 80% of the recovery from heap leach. As you can see in this graph, the y-axis shows copper extraction and the x-axis shows the days of the leaching. So in around 150 days, we could be able to extract 80% of the copper. The second example is a single heap dual system leaching. This test was done on copper oxide with significant gold in it. So the head grade shows 0.22 gram per ton of gold and 0.5% of the copper. We did this in two stages. The stage one was the GlyLeach. We did it to extract the copper, and we could be able to extract around 80% of the copper during 35 hours of the leaching. After that, we introduced the cyanide to the system to extract the gold, and we reached around 90% of the gold extraction. The third example is related to copper flotation tailing in Zambia. We did use two of our technologies for this specific sample, both GlyLeach and GlyAm. For both of the technology, we are able to improve the extraction using a small amount of the acid. As you can see in this graph, the y-axis shows copper and cobalt extraction, and x-axis shows different technologies that we have used. For example, for the first one, GlyLeach would be able to extract 63% of the copper and 1% of the cobalt. If we do the acid procuring before the test, we could be able to extract even more copper, around 71% copper and 7% cobalt. For the GlyAm system, again, it's the same. If we do the acid curing before the test, we could be able to increase the extraction of both copper and cobalt. The next example is related to carbon-hosted copper oxide. In this graph, you can see that the y-axis shows cumulative copper extraction and the x-axis shows days under leach. The dark blue one shows GlyLeach and the light blue one shows sulfuric acid leach. This specific ore type has 0.5% of the copper. As you can see, after around 120 days of the leaching, both of the GlyLeach and sulfuric acid reaches the same copper extraction, around 80%. However, for the acid test, we use 98 kilogram per ton of acid, but for the glycine, we only use 0.2 kilogram per ton of glycine. So obviously, we can reduce the amount of chemicals. This slump test is related to previously test work that we've done for the same sample, and it has 0.5% copper in it. The first, we did have two samples, sample 1 and 2, and we did the slump test. But for the sample 1, for the acid slump, as you can see, it was around 20% slump that stopped the percolation of the fluid. So we had to terminate that one. But for the sample 2, it was less than 5%, but still GlyLeach was acting better, less than 2% slumping. So we use a cement for agglomeration, which this way we can minimize the slumping. That's all I've got for the case study of copper. Now I hand over to Dr. Yang Hu, that she's going to talk about nickel.
Thanks, Ilahi. I've got two case studies for extracting nickel and cobalt. So the value for using GlyLeach to extract nickel and cobalt is it is cost effective and environmentally friendly. It is particularly used for nickel sulfides. It can leach nickel and cobalt from tailings with a recyclable and eco-friendly reagent. So, and it is also highly selective, produces a high purity product that doesn't require smelting. And it can dramatically simplify the flow sheet and eventually reduce the carbon emissions. Now I will move on to the first case study, which is a nickel concentrate bearing PGMs and gold. With this particular sample, it has around 12% of nickel, 0.3% of cobalt, 1.9% of copper, 0.7 gram per ton of gold, 1.7 gram per ton of platinum, and 4.3 gram per ton of palladium. The technology we used here is GlyAm, which is essentially using glycine and ammonium to maintain the target pH. So in the bar chart you see here, on the y-axis is the extraction based on the residue and acid head, and the x-axis is the actual metal extracted. We have done two set of tests using different glycine dosages. The light blue bars showing the extraction results based on glycine dosage of according to the molar ratio of 2 to 1 to nickel. As you can see, there were 74% of nickel extracted, and similar for cobalt. And for copper, it managed to extract 87%. And in the same time, the gold, 78% of gold was extracted, and 53% of platinum, and 64% of palladium extracted. If we further increase the glycine dosage to a molar ratio of 6:1 nickel, the extractions can be further increased. Especially for nickel, cobalt, and copper, all of them achieved over 90%, even 97% of extraction. For platinum, there's a big increase in terms of extraction as well, from 53 to 97%. And palladium also increased from 64 to 76%. The key takeaway from this case study is that GlyAm allows extraction of base metals, gold, and PGMs in the same process. Next case study is related to a tailings sample. So this particular material has only 0.4% of nickel, 0.01% cobalt and copper. With Glyleach, which is using sodium hydroxide to adjust the pH and maintain it, a 57% of nickel was extracted, further reducing the nickel residue grade to 0.8%. In the same time, we also achieved 45% of cobalt extraction and 51% copper extraction. The table below is showing the typical PLS compositions. As you can see, the main metal in the PLS is nickel, cobalt, and copper, and sulfur due to the oxidation of sulfide. And the iron, magnesium were kept minimum. As you can see, Glyleach allows minimum dissolution of iron, producing a cleaner PLS for downstream processing. That's all from me. Now I will hand over to Mente to talk about our engagement model.
Thank you, Yang. I'll be taking you through our engagement model. If there is an interest in evaluating or testing our glycine leaching technology, we follow a stage gate review approach to de-risk the project and offer value to our client. The first stage is what we refer to as the discovery program test work. The stage is aimed at assessing the amenability of GLT to the respective ores. This test work, it is highly recommended that it's done in our laboratory in Perth, just to establish baseline conditions for GLT for the respective ore, and an NDA has to be in place for this work to be conducted. Subsequent to that, this is followed by extensive laboratory testing, piloting, and ultimately commercial and demonstration scale. This stages can be done at a client site upon signature of a royalty-free commercial license for a period of a year. The reason why this is done is because GLT is a patented technology and is governed by IP law. The indicative cost per stage and the preliminary schedule per stage is also shown in this table. Post completion of each and every stage, we have a client review meeting, which is aimed at advising and recommending to the customer if comparing GLT with conventional leaching processes to offer best advice to our customers. So the ultimate goal, obviously, it's a commercial use license. With the commercial use license, we've got two options, which the first option is a upfront license fee, which is a once-off payment, which is based on the size of the operation. This can be spread out over a fixed period of recurring payments if required, and it is negotiated side by side. Another option is a subscription fee model where we offer continuous value add to the operation, ensuring that we offer optimized plant operation and also targeting improved metal recoveries. This allows us to do knowledge transfer from new technology development that is done in our labs, and also offer audit to the license operation by ensuring that it's governed by best practices that are being deployed. Thank you.
Thank you so much, Mante and panel. I'd just like to point everyone to some sources of additional information. On our websites, we have quite a few content pieces, from brochures to videos and infographics. It's a treasure trove of insights into this technology. Also ask that everyone follow us on LinkedIn. We post regular updates on the clients that we're working with and test results. So if you'd like to know more about the technology and how it's progressing commercially, please stay up to date on LinkedIn. Okay, great. So while we're waiting for the last few questions from our audience to come through the Q&A section, I'll just ask the panel a few questions that we get quite regularly from our customers. So the first one is there any impact on other processes, and does the leach time need to be increased? Glenn, would you like to answer that one?
So yeah, with the downstream processes to actually recover the dissolved metals in solution, we have tested all the known different processes, and it worked with if no known effects. That is, we can use salt extraction, unextracted resins, or precipitation to recover the base metals, and precious metals we can use absorbents or actual activated carbon to load onto out of solution. So yes, there's no real ill effects using our technology. The leach time does depend on the application. Typically with temperature, we can improve the kinetics of leaching, but with some base metals, it may require additional time over the existing tenolate acid to improve the extraction. But overall, we were able to achieve or maintain the similar extractions to what existing technology showed.
Great, thank you. Mante, what is the cost of glycine compared to traditional processes, or the cost of this technology?
So Megan, with the test work that has been done to date on the samples that have been tested, we've seen significant decrease in the reagent cost of when using GLT compared to conventional leaching technologies. I don't want to say cyanidation because we're talking about base metals here. So there is a significant decrease in the reagent costs when using GLT.
We have a question from Shane. Mante, could you take this one? Can you explain more on how the subscription fee works compared to paying for the product itself?
So with the subscription fee, we offer continuous support to the operation. That is allowing for the work that is being done in the lab by our development metallurgist. We offer continuous feedback to ensure that the plant is being operated as per best practice.
Right, Glenn, we have a question from Tony. How does the process control the dissolved oxygen in the GlyAM technology process?
Oxygen as an oxidant for leaching or base metals is needed, as we need to go to 2+ state to form metal complexes. So yeah, oxygen is very crucial to the actual process, but the degree of oxygen is probably not as much as other technologies. We only need air addition to basically oxidize the metal ions into solution.
We have a question from Torolev. Can GLT be retrofitted into existing mine operations? Does it require a lot of changes to downstream processing of leach solutions?
I think the short answer is no. We've seen good extraction using just the tank leach. So the existing flow sheet should be easily modified to suit the conditions required for gly leach.
We have a question on how do you plan to collaborate with your potential customers in Southeast Asia? Do you have a presence in Asia? Glenn, do you want to take that one?
Yes, we do have regional leaders around the world, and we are building up that area. And within the next month, we should have some representatives who can you deal with to discuss the glycine leaching technology.
We have another question from Tony. With internal recycle of glycine, how does the process design deal with the buildup of unwanted salt?
So what we have observed with the GLT is that it does not dissolve impurities such as aluminium, iron, and manganese. However, if there is an buildup of impurities in the recycle stream, such as sodium and calcium, there can be a bleed out that is done.
Glenn, do you have anything you want to add to that?
Yeah, usually when dealing, it's all about water balance. So therefore, with nanofiltration, you can use to able to recover water or disclude sodium and calcium in that stream to maintain a balanced solution for leaching.
Another question is, would it be more typical to use hydrogen glycinate or sodium glycinate in glyleach? Hydrogen glycinate would demand more acid neutralization, right?
Typically, there is sold as hydrogen glycinate for the food industry, but Dosloka is developing a sodium glycinate or laboratory grade, you could say, reagent, and that would be more applicable to the glyleach and glyam technologies where it's in the alkaline range.
We also have a few questions on gold. So this would be around our glycat technology. The question is, so for effective gold leaching, we will always need cyanide. What are the benefits of glycine versus cyanide alone?
Just so you're aware, glyleach alone can leach gold. You don't need cyanide present, but the application where we have glycine with cyanide does increase the kinetics and reduce the amount of reagents needed to extract and the precious metals in the ore. So overall, we see very similar extractions to slightly higher extractions and much reduced reagent additions to what you would cyanidation.
Thank you so much for joining us on this webinar. We will be sending additional resources via email to the email that you registered for the webinar with. If you have any questions, please don't hesitate to reach out to us. Our team is more than happy to answer any more of your questions, and we'll see you next time.